a geometric ratio is different than an arithmetic. A geometric is going to show multiplication or division as opposed to adding or subtracting. So, I want you to keep in mind the format for this is a sub n is equal to a sub 1 times r to the n minus 1 power, where a sub n is our nth term, so whatever term we're talking about, the 15th, the 20th, whatever. A sub 1 is just like before. This is our first term. R is going to be our common ratio, and that is going to be our multiply or divide number. So if we go over here to our example notes, we have this sequence on the right, which is talking about the baseball brackets. It says the number of teams in each round can be represented by the finite sequence. Finite means it ends 16, 8, 4, 2, 1. And I want you to remember this is 1, 2, 3, and 4, and 5, where this is our n, and then this is our a sub n. So our recursive rule is a little different for geometric. Remember, recursive means you need to have the one before. The common ratio r is 1/2 because we're dividing by 2 or times 1/2. So they've written it a sub n minus 1 over 2. We could also write 1/2 a to the sub n minus 1. Okay? Our explicit formula says that we have, no, you're good, says that, again, a sub 1, which is 16, and then we can write 0.5, we can write 1/2 into the n minus 1 power. So the arithmetic sequence has a common difference, that was our D, and a geometric sequence has a common ratio. So if we graph this, this is going to look different than when we graphed our arithmetic. So we have our teams and we have our term number here. So we're starting with 1 is 16, 2 now is only 8, 3 is going to be 4, 4 is going to be 2, and then finally we have at the 5th term we have only one team. So keep that in mind when you're looking at geometric sequences. So you can see that if we needed to connect this dot, it's going to be a curve. So I want you to finish this bottom piece, and we'll look at it in class.